Okay, this is my version of problem number 24 from section 11.3. And we want to find the area that's shared by the circle r equals 5 and the cardioid r equals 5 times the quantity 1 minus cosine theta. So hang on a second. So let's assume that we have this circle of radius 5. And we want to begin to plot the cardioid for on top of this circle. So what we want to do is basically think about what happens when theta is 0. Well, when theta is 0, cosine of theta is equal to 1. 1 minus 1 will be 0, and so r for the cardioid will be 0. We'll plot this in a different color. Will be 0 when theta is 1. Then let's see what happens. Let's go through some good values, easy values. Pi over 2. Well, at pi over 2, we know that cosine is 0, so 1 minus 0 will be 1, and so r will be equal to 5 at pi over 2. And so with a cardioid, then let's do at pi. At cosine of pi, we're going to get a negative 1, so 1 minus negative 1 will be 2, and 5 times 2 is 10. So at pi, we're going to be way out here at 10. And so from that, hopefully you can see that this cardioid is going to do something like this, and the cardioid is going to be symmetric about the x-axis here, and it's going to come in and do something like that. And we can double check that these two curves intersect, and we'll find where they intersect right here. We have r equals 5, and we have r equals 5 times 1 minus cosine theta, and so we can set them equal to each other and solve for theta. We'll get 1 is equal to 1 minus cosine theta, and cosine theta is equal to 0, and that happens when theta is pi over 2, or when theta is equal to 3 pi over 2. And we can see that from our graph that that is true. Now what we want to do is we want to find the area that's shared by the circle and the cardioid. So the area shared by the circle and the cardioid really is made up by two sections. And in purple here, I'm highlighting what is just a semicircle, or half of a circle. And then in blue, I will highlight this other area here that is just outside of that semicircle. And so the easiest way to solve this problem is really to find the semicircle, or the area of the semicircle. So for example, 1/2 of pi r times 5 squared would be 25 pi over 2. So we have a circle of radius 5, and its area is 25, would be pi r squared, or 25 pi, and we want half of that, so it's 25 pi over 2. So that is the purple area there. So you can see what's left for us to solve is simply the little bit of area that's outside. And since there's two of them that are symmetric, we only need to solve for one and multiply by 2. So what we have to figure out next is what are the angles that constitute, that we have to sweep through to pick up all of that area that's in the first quadrant, and it turns out to be 0 to pi over 2. So we know then that area of a polar segment is 1/2 integral theta sub 1 to theta sub 2 r squared d theta. And so in this case, all that we need is, we're going to take 2 times, for the two different little pieces, times 1/2 from 0 to pi over 2, and we're only working with one curve. We're working with the cardioid curve, so that would be 5 times 1 minus cosine of theta d theta. And that's all squared. It's r squared. Alright, so that's 1/2 r squared d theta from 0 to pi over 2, and the 2 and the 1/2 should cancel out. Then the next thing I'm going to do is I'm going to square the 5, and that becomes 25, and we can bring that out. So the 2 times 1/2 cancels out, and we get 25 on the outside. Integral from pi over 2 to integral from 0 to pi over 2 of 1 minus cosine theta d theta, 1 minus cosine theta quantity squared d theta. Now the only way that we're going to be able to integrate that is we have to multiply that all out, and it gets messy, but we don't have any other choice here, and we're going to need a trig identity to complete this, to complete the integration part of it. So we have 1 minus 2 cosine theta plus cosine square of theta d theta. Now all of those pieces are fairly easy to integrate except the cosine square of theta, and we do have an identity that says cosine square of theta is equal to 1/2 of 1 plus cosine of 2 theta. If we were looking for sine square of theta, then that would be 1/2 of 1 minus cosine of 2 theta. So it's annoying, but they're not too, they're close enough. The sine has the minus, the cosine has the plus. So again, I'm going to rewrite, and we get 25 times the integral from 0 to pi over 2, 1 minus 2 cosine of theta plus 1/2 times 1 plus cosine of 2 theta and d theta. So however many steps you want to go through to get this, now we have to apply that 1/2. So we're going to have 1 plus 1/2. So I'm going to get a 3/2 in here. Then minus 2 cosine of theta. And then plus 1/2 cosine of 2 theta d theta. Now, the only thing that we're going to need a substitution on is the cosine of 2 theta, but those work pretty straightforward. If this were derivatives, the derivative of cosine 2 theta would be negative 2 times the sine of 2 theta. Since it's an integral, we're going to get, so we have 25 integral 0 to pi over 2 3/2 minus 2 cosine theta. Sorry, I'm going to step back. I'm ready to actually do the integration at this point. So I have a 25 on the outside. 3/2 becomes 3/2 theta. Negative 2 cosine theta is going to be negative 2 sine theta. The integral of cosine is simply sine. Then, for this last piece, the antiderivative of cosine of 2 theta would be 1/2 sine of 2 theta, and we already have a half there, so it's going to be 1/4 sine of 2 theta d theta. Sorry, there's no more d theta. We're just going to close the bracket there and integrate that from 0 to pi over 2. Now, if you wanted to take offline the integral 1/2 cosine 2 theta d theta and do a u substitution with u equal to 2 theta, you'll see that you end up with this 1/4 sine of 2 theta as your antiderivative there. Alright, so we're ready to go ahead and evaluate this. We have 25 times, and we're going to have two things going on here. So I set up my parentheses. 3/2 times pi over 2 is going to give me 3 pi over 4. And then sine of pi over 2 is 1, so that'll be minus 2. And sine of 2 times pi over 2 would be sine of pi, and that is 0, so that other term goes away, fortunately, over there. Then when theta is equal to 0, the second term completely goes away. And the second expression completely goes away. And so now we have 25 times 3 pi over 4 minus 2, which is 75 pi over 4 minus 50, or 75 pi minus 200 over 4. But we still need to add the 25 pi over 2 for the semicircle onto that. And so if I do that in red, I'd have 25 pi over 2 plus 75 pi minus 200 over 4. And so if I multiply that, we'd get 50 pi over 4 plus 75 pi minus 200 over 4, or 125 pi minus 200 all over 4. And when I type that into my screen there, you can see that. Fantastic. So that's the way that that this problem works, and hopefully that is helpful. Okay, we'll stop this video. Let me go back for a second and let's see if we can re-explain some things. Alright, so some of the important things here is you have to be able to plot the circle, obviously, and you need to be able to plot the cardioid there. You need to be able to identify what is the shared area. You could also have the area that's inside the circle that's not in the cardioid, the area in the cardioid that's not in the circle. The problem could be stated in any of those ways. We need to find the points of intersection, and in this case, wherever you can use geometry or circles or semicircles, then obviously that's going to help your calculations a little bit, make them simpler, sorry. And so we just have that one little piece that's kind of symmetric in the first and fourth quadrants, and we need to sweep from theta equals 0 to theta equals pi over 2 to pick up that area there. And so I think we're going to stop at this point here.